Hey guys, hopefully you've watched the other two videos so you have a good idea of what we're getting ready to do. And so we are going to take this trinomial, and because it's quadratic, and because it's a trinomial, and because a is equal to 1, we know that we're going to end up with two binomials. So if you're doing step-by-step notes with me, hopefully you've got your learning target, you've got the first problem right here, and our first step is that we're going to set up empty binomials. So we know that when we get finished, more than likely, we're going to end up with two binomials that are being multiplied by each other. So step 1, we set up those empty binomials. Step 2 is that we need to factor. Remember, that means we're going to pull apart into pieces. Basically, we're going to unmultiply the first term. So in this case, that first term is an x squared. Well, the only way that you can factor an x squared is if you do, the only way you can pull it apart is by doing an x times an x. So you're taking that x to the second power, you're pulling it apart into those two pieces that you multiplied to get it, the x and the x, so you know that that is going to be the front of each binomial. Then for the next step, you're going to make yourself a table. And you need to ask yourself two questions. The first question is, what can you multiply? So what can you multiply to get C? So in this particular case, remember that C, if you don't know what I'm talking about, please go back to the previous videos. C in this case is 6. So what can you multiply to get 6 is going to go on the left side of your table, but it can't just multiply to get 6. So what can you multiply to get 6? I'm going to add to my question over here that you can add to get B. In this case, B is that 5, right? So what can you multiply to get 6 that you can also add together to get 5 in this case? So I'm going to try to figure out, well, what are the numbers that I can multiply to get a positive 6? Well, I can multiply 1 times 6. I can multiply 2 times 3, and that's it, right? Because those are the only factors of 6. So can any of those add to get 5? Well, as it happens, yes, right? Because 2 times 3, if you add 2 plus 3, you also get 5. So those are your two numbers that are going to go inside of your binomials. So you're going to put, so it's going to become x plus 2 and x plus 3. So the numbers from step 3 are going to go right there. So now you have just taken the expression and you've split it up, you've unmultiplied it into the two binomials that you started with. Now a lot of you guys probably already knew that that was the answer you were going to get, right? Because we already multiplied this problem earlier. So let me show you where these parts came from. So notice when we went back and we multiplied, once we did all the pieces of multiplication, we had these two middle terms right here that added up to get that middle term. So that's why when we're factoring it, we have to figure out what are the two numbers that are going to add up to get 5. So that's where the 2 plus 3 came from. But then we also need to know what's going to multiply to get 6, because you had to multiply these two numbers here. That 2 times 3 is what gave you 6 when you did the multiplication problem. So that's where in our table multiplying by 6 came from. So again, you always have to take whatever you multiply to get C, and that'll add to get B. And that helps you to factor it. So your final answer, okay, we've taken it, we factored it apart, is x plus 2. Ooh, that was messy. And x plus 3. So here's another example for you. And so I'm going to walk you through the steps again. I'm not going to write the steps out step by step this time, but I am going to talk them through while I'm doing it. So your very first step, you should have those written in front of you, I hope. So your very first step, you can tell that this is quadratic because it's got the 2, and it's a trinomial because you have 3 terms, and the number in front of the x squared is a 1. So you know that if you get done factoring this, if you get done pulling it apart, more than likely, I don't want to say always because we are going to run into some examples where it doesn't work, but most of the time you're going to end up with 2 binomials just like so. So your first step, ooh, ugly parentheses. I'm going to set up my empty binomials and get ready to fill them in. Step 2 is to take that first term, take that x squared. The only way to pull apart an x squared is to, again, factor it into x times x. So that part's always the easy part. Step 3, we need to set up a table. And remember that you need to figure out what can you multiply to get C. So in this case, C is 20, that will add to get B. And in this case, B is not just 12. Pay attention to the fact that that's a negative 12. Okay? So I personally think it's always easier to just start off with them. Actually, it's definitely easier. It's not even that I think. It generally just is. For you to start off with trying to figure out the factors, like what you're going to multiply first. And don't sit there just trying to think of a bunch of random numbers, okay? Go in order. So, for example, like I know I'd get 1, like to get 20, I can multiply 1 times 20. Then I know the next number I could try is 2 times 10. 3 does not go into 20. 4 does, right? I got 4 times 5. And now we know that we're finished with all the factors because the next number we would try is 5, but 5's already there. So we know we have all the factors of 20. Well, my problem is, though, that I don't see any of these that add up to negative 12. But I do see something kind of close because if I add positive 2 and positive 10, that'll add up to a positive 12. So I think there's something there. Don't forget that, yes, a positive times a positive is a positive, but also a negative times a negative is also a positive. So there's actually more factors here that will get you a positive 20, right? You can do negative 1 times negative 20. You can do negative 2 times negative 10, negative 4 times negative 5. And then there we go, negative 2 plus negative 10 also adds up to negative 12. So you know that those are the numbers that you're going to put inside of your binomials. So you've got x minus 2 and x minus 10. So my final factored version of this expression is x minus 2 times x minus 10. Example number 3. Again, we've got a trinomial because we have 3 terms. It's quadratic because it has that exponent of 2. And there is a 1 there in front of the k squared, so a is 1. So we know our first step is that we're going to put in these empty binomials because more than likely there's going to be some empty binomials that we're going to fill in here. Step 2, we are going to factor that first term. And even though it's not an x, don't let that freak you out. It basically just means the same thing. Remember, variables are interchangeable. So the only way to factor a k to the second power is still to do a k times k. So that is going to become my first term. Then I'm going to set up my table. And I'm going to try to think to myself, what can I multiply to get c? So what am I going to multiply to get 20 or negative 24? Sorry. Then I'm also going to be able to add to get negative 5, because it's what can you multiply to get c. You can add to get b. Careful about those negatives. So this one's a little trickier because that negative 24 is a negative, right? So let's just figure out what the options are for just the numbers you can multiply just to get a plain old 24. And there's a lot of them, so let's go in order so that we don't forget one. So we've got 1 times 24. We've got 2 times 12. 3 times 8. 4 times 6. 5 does not go into 24, and we know that we're done because we've already wrapped back around and we've got the 6, and the 6 would be the next number we would try. Now, obviously, if you multiply these two positives together, it is not going to give you a negative. So the only ways they could do it is either if the first number were negative, okay, so that's a possibility, or the second number would have to be negative. So it would be 1 times negative 24, 2 times negative 12, 3 times negative 8, and then 4 times negative 6. So there are actually 6 different possibilities of combinations of numbers that you can multiply together to get a negative 24. Now, which one of those adds to negative 5? Ding, ding, ding. This would be it right here. 3 plus negative 8 are the two numbers that you would put in there. So I'm going to fill in the binomials with a k plus 3 and a k minus 8. So the fully factored form of this trinomial is k plus 3 and k minus 8.